This is Geometry Lesson 2.2. Today we're going to be talking about the number patterns again, finding the nth term, which would be like a function equation, learning some new vocabs, and practicing the inductive reasoning. So a quick review, we need to look at our data here in our sequence, and we need to figure out what the rule is that's happening to each term to get the next two terms. It does say round to the nearest hundredth. And remember, when you're rounding to a hundredth, let me just give you an example here. Let's say this was our number. This would be the ones spot, and then we have our decimal. This would be the tenths, hundredths, thousandths. So if we're looking for the hundredth spot, that would be right here. And I always want to look at the previous number. If that's a 5 or bigger, I would have to round this number up before I chop off the rest. So I'm looking at 65 down to negative 16.25 and then to 4.0625. And I notice it goes from positive to negative, positive to negative. So that kind of indicates to me that we're either multiplying or dividing by a negative number. And in this case, if I test it out, if I take my 65 and divide by the negative 16.25. Let me just grab my calculator here. 65 divided by negative 16.25. It comes out to negative 4. I'm going to try it again. I'm going to take this negative 16.25, divide by the next term, which would be 4.0625, and that also comes out to negative 4. So I know that I'm dividing by negative 4 each time. So my rule is dividing by negative 4, so I'm going to take this term and divide by negative 4 as well. Negative 1.015625 divided by negative 4. And the number comes out to 0.25390625 is what my calculator will show me. So if I'm looking for the hundredth spot, that would be right here at the 5. I'm going to look at the number behind it, which is a 3. Because it's smaller than 5, I can just chop all this off. So this would be 0.25 here. And then I'll divide by negative 4 again, and I get the number negative 0.06. And that is rounded. All right, finding the nth term. The nth term is going to be our equation. So that we can find it for any term number. N stands for whatever term number we are looking for. So for example, this would be the 8th term here. So first I want to look at how my terms are increasing in this case. From 20 to 27, 27 to 34. I want to look for, are they adding something every time? Are we multiplying by something every time? And in this case, it's adding 7 every time. So if I take 62 plus 7 more, I get 69, and then I add 7 again, and I get 76. So the next two terms in the sequence would be 69 and 76, and we're adding 7 each time. Now remember, when you add something each time, that would be called your rate of change, also known as your slope. This is linear because we are adding. Alright, so now if I kept going, I could find the 200th term, but that would be a really long table. So how else could we find the 200th term? So I need to figure out what number am I starting at, and then if I'm adding 7 every time, I need to add 7 200 times. So basically, I'm taking 200 times 7, and then I have to add on the starting value, and the starting value is also known as the y-intercept. So in order to find the starting value, it would be kind of like finding the 0 term right in here. So I need to go back one stage. And if I'm adding 7 to the right, I would subtract 7 to the left. And that would get me 13 for the starting value, or the 0 term. And so that would get me my 200th term, and it comes out to the value of 1,413. So the rule then, instead of putting in what term we want, we would put in the value n for the nth term. This was the 200th term. Now usually your variable goes after the number you're multiplying by. So it'd be 7 times n plus 13. It's also sometimes written with the starting value first and then the slope or rate of change. Either way is correct. Now we are talking about function rules in this case. So a little reminder from algebra would be the function for term n, and then we have our linear equation here. So here's the definition for function rule, a rule that gives you the nth term for a sequence of numbers, and just as a placeholder for any term number along the table. So here's some examples. Now we have the nth term, so usually it starts at 1, but really it could start anywhere giving us the data. And then here's our function rule for each of these. Now I've covered up the rest of the tables here. Let's just look and see if we can figure out what's going on. So if I'm looking here, we can look and see if we can find the change or what's happening each time. So if I'm going from -4 to -3 to -2, it's going up by 1 each time. Here it's going from 1 to 5 to 9, so that's adding 4 each time. So what I'm trying to find is the difference. So if we look here, the differences are how the values are changing, and I've already filled all those in for us. So you can see here, this one is subtracting 5 each time, so the difference is -5. Now we want to look at our function rule and see where those occur. So if I'm looking for this -5, I notice that my difference is always next to the nth term. +3, right here next to the nth term. -2 because it's going down by 2, so it's next to the nth term. So our differences, how it's changing, is always next to the n value, or the term number. This other number would be our starting value, or our y-intercept. So the other number, it doesn't show up on the table right now because we don't have our 0 term. So if I were to plug in one more column here for the starting value, that would be where this value is. -5 would go right here. Because from -5 to -4, I have to add 1. If I go backwards, I would be subtracting 1. So on the 0 term here, this would be -3. On the 0 term here, it would be the +5. The 0 term here would be -2. And the 0 term here would be the +7. Alright, so here we have a sequence of numbers, and it says make the table. So I always like to start with the 0 term, but for this chapter, they're going to start with the first term usually. So I'm going to put 1, 2, 3, 4, 5, 6, 7. And then we're just going to plug these in. So the first term is a value of 7. The second term is a value of 2. The third term is -3. The fourth term is -8. -13, -18, and then we're not sure of the next one, but we could figure it out. Step 2 says find the difference, so I need to know how is it changing each time. And if I go from 7 to 2, we are subtracting 5. Next thing is to find the 0 term, or the y-intercept, the starting value. So I need to go back one step, so instead of subtracting 5 to the right, we're going to add 5 to the left. So 7 plus 5 would give us 12. And then to write the rule, our difference goes next to the n value, and then we either add or subtract depending on what the 0 term is. So since the 0 term is +12, I'm going to put +12. And I could write it as function notation with that function rule there. And as I said before, this is linear. So if we were to graph that equation, it would create a straight line. The 12 would be on the y-axis, so if this kept going, it would cross right here at the 12. And the -5 is really -5 over 1, the rise over run. So I'm going down 5 over 1, down 5 over 1. All right, in these we just have to decide if it's linear. To be linear, you'd have to be adding or subtracting a constant. So from 8 to 15, 15 to 22, I'm just going to take my calculator. I'm going to start by subtracting 8 from 15 on that first one. So 15 minus 8 comes out to 7. And then I'm going to take 22 minus 15 and see if that comes out the same. And lo and behold, it does. So yes, this would be a linear function. I'll do the same thing here. So I'm going to take the second term, -6, and subtract -9. So -6 minus -9 Comes out to positive 3, so it looks like I'm adding 3 here. I'm going to do the same thing for a negative 2 minus the negative 6, and I get positive 4. So because I'm not adding consistently, this is not a linear function. 14 down to 11 is subtracting 3. 11 minus 3 is 8. 8 minus 3 is 5, and 5 minus 3 is 2. So because I'm subtracting 3 every time, this would be linear. Now this one's a little bit more complex because it is fractions, so feel free to use your calculator. We're going to take negative 1 minus the negative 3 halves. So I'm just going to type negative 1 minus negative 3 divided by 2. It comes out to 0.5 or 1/2. And now this is saying that it's a positive 1/2, so I'm going up by half. And if I look at this one, that does increase by half, increases by half, increases by half. So this would be yes. Now you could have also changed this to decimals, and that might have helped you see the pattern. Alright, for these exercises we're going to complete each table. Remember the change, the difference, the slope would be next to the n. The 0 term would be the other value. So I'm going to just add in a 0 column, and negative 12 would go here. So then I'm going to use my change, my difference, and it's a positive 7. So I need to add 7 to negative 12. So I'll just type in my calculator, negative 7 plus 12. I'm sorry, negative 12 plus 7, and that comes out to negative 5. And then we'd add 7 again, and that would come out to positive 2, and we'd add 7 again, and that would come out to 9, and so on. The same thing here, add a 0 column, put in your y-intercept, your starting value, your 0 term, and then this one says negative 8, so I need to subtract 8, so that would come out to negative 10, this would be negative 18, and so on. And this will be the assignment that we're practicing in class for this lesson.